Now we are done with the molarity. Now the another concentration term that we are having is molality. Do not get confused between the names molarity and molality. One is molarity, that is discussed before this. Molarity, what was molarity? It is number of moles of solute present per liter of the solution is termed as molarity and represented by capital M. Now we are going to study about the molality. What is molality? Number of moles of solute present per kg of the solvent is termed as molality. I am repeating, it is number of moles of solute present per kg of the solvent is termed as molality, and it is represented by a small m. Okay, so the formula of molality is moles of solute by, that is as per the definition, number of moles of solute per kg of the solvent. So moles of solute upon per kg means mass of solvent in kg. As we have expanded the formula in the molarity, we can also expand this formula as well. The formula of the moles remains same. That is, what is the formula of mole? First, it is represented by small n, and the moles is weight upon molecular weight. So here we can apply small m, that is stands for molality. It is small w into, that I will discuss, into 1000. Okay, then molecular weight upon molecular weight. Here we are going to apply the moles, and then mass of solvent in kg. Then mass of solvent, that we are going to take it as W in grams, because if we have taken gram, then we have to apply it by 1000. Okay, so moles of solute by mass of solvent per kg is termed as molarity, and if we are going to expand it, then weight into 1000 upon molecular weight into weight of the solvent. Okay, now we need to know, that is, what is the difference between these two. It is small w is weight of solute. Okay, m represent what? A capital M. Here I think there is no chances to get confused. So m is molecular weight, obviously, and W, what is capital W? It is weight of the solvent. I am going to discuss one example that we have discussed also in the molarity. First, I am going to discuss one numerical that is based on the. Now we are going to discuss a numerical that is based on the molality, and what it is. It is find the mass of NaOH, that is sodium hydroxide, which should be dissolved in 1 kg of water to obtain a 0.1 m, that is molar. If small m is written, then it is termed as molar. Okay, molar solution. Then I am repeating the question again. It is find the mass of NaOH which should be dissolved in 1 kg of water to obtain a 0.1 m solution. Okay, now the values that we are having, 0.1 m. So the molality is given in the question. So molality is, small m is 0.1. Okay, it is 0.1. How much amount of solvent is present? 1 kg of water. So 1 kg is equals to 1000 gram. Molecular weight, again, that I already discussed in the molarity, how to know the molecular weight of the given compound. So the same formula you are going to apply over here, that is the molecular weight of the NaOH will be 40. So now we are going to apply the formula of molarity first, that is m is equals to W into 1000 by molecular weight into weight of the solvent. Excuse me. And molality is also already given. Then what they are asking about weight of solute, because capital W represent the weight of solvent, that was given, molecular weight was given, and molality is given. Then what is left? Weight of the solute is left. So weight of the solute, if we are going to multiply it, then molality into molecular weight into weight of solvent by 1000. Is it so? Yes. So 0.1 into what is molecular weight? 40 into 1000 by 1000, 1000 cuts. 4.1 multiplied by 40, the answer is weight is equals to 4. Yes, it is. What is the molality of the given numerical? It is 4. So I hope you are getting this key. Now we are done with the another concentration term, that is molality. What is molality? I am repeating. It is number of moles of solute per kg of the solvent is termed as molarity. M is equals to number of moles of solute by mass of the solvent in kg, and on expanding the formula we are getting this formula, that is weight into 1000 molecular weight into weight of the solvent. And this numerical, I hope it is helpful to you. After this we are going to discuss all the numericals that I already mentioned in our last video. Okay, now we are going to discuss another concentration. Now another concentration term we are going to study the another concentration term is normality. What is normality? Normality is number of gram equivalent of solute per liter of the solution. What is normality? I am repeating. It is number of gram equivalent of solute per liter of the solution is termed as its normality of the solution. That is, it is represented by the capital M, and the formula of the normality is number of grams equivalent of solute. It is equivalent of solute by volume of solution in liter. And another formula that is a kind of shortcut, it is a short trick. The normality is equals to molarity into F factor. F factor, I said. It is F factor, and how will you identify what is the F factor if molarity is given? And normality they are asking, that we are going to discuss in the numericals. But here you can take some idea of it, that F factor is if number of OH ion is present, that is F factor you can find out. That is acidity of the reaction. If number of OH ion is present, that also you can find the F factor. And if charge is present, whether it is positive or a negative charge. So normality formula, two formula we are having. First is number of gram equivalent of solute by volume of solution in liter. Another one is normality is equals to molarity into F factor. How will we identify the F factor? By counting the number of OH ion, or if number of H ion are present, and if the charge is present in the given compound. I am repeating the definition. It is number of gram equivalent of solute per liter of the solution is termed as its normality. Now we are going to discuss the another concentration term. The another concentration term is mole fraction. Now what is mole fraction? Mole fraction is number of moles of solute or solvent to the total number of moles present in the solution. What is mole fraction? It is number of moles of solute or solvent to the total number of moles present in the solution. For example, if we are going to take the binary solution, I hope you remember in the first video I discussed about types of solution. Binary, I said, binary, ternary and quaternary. On the basis of components, I said on the basis of component, three types of compounds are there. So binary means two components are there. So two components are there, then it is termed as binary solution. So if we are going to apply the mole fraction in the binary solution, then we are having this formula. The mole fraction is represented by the X. So if we are going to take the two components, that is A and B component. One component stands for A and another one is for B. Now X represent what? X represent mole fraction. So XA, as its definition says, number of moles of solute or solvent to the total number of moles of total number of moles present in the solution. That we are going to apply. Then if the component is A, this is for A component, then mole fraction of the A component is moles of A component, Na, then it is number of solutes, then moles of solution, that is Na plus Nb. That Na stands for number of moles, that is moles of solute, then moles of solute again by moles of the solvent, that stands for the solution. As I already discussed, if you have to take the solution, then you have to take the mass or the moles of solute and the solvent. So the mole fraction of A component is Na, that is moles of A component, by the solution, that is Na plus Nb, because in solution both the things are present, and in this Na, this stands for the solute for the A component. Then if we are going to take the B, then Xb is equals to Nb, that is moles of B component, okay, then moles of solution Na plus Nb, that is moles of A and moles of B together termed as moles of solution. Now we also write it in this way, that is Xa plus Xb is equal to 1. Or if we want to know what is the mole fraction of Xb, then it will be 1 minus Xa. So I hope you are getting this. What is mole fraction? It is number of moles of solute or solvent to the total number of moles present in the solution. If we are going to take the binary solution, what is binary solution? If two components are present, then it is termed as binary solution. Two components, we take it as one is A component and another one is B component. In A component, we termed it as X. X represent what? X represent mole fraction. Mole fraction is denoted by the X. So Xa is equals to moles of A component to the total number of moles, that is Na plus Nb, that is moles of A component and moles of B component. The same we have applied in the component B, that is Xb. It is moles of B, moles of B component, then total number, that is moles of A component and moles of B component. Now Xa plus Xb is equals to, it is always equals to 1. Then Xb is equals to 1 minus Xa. So here we are done with the another concentration term, that is mole fraction, and numerical I will discuss in the solution part 3. Many times I mentioned this. Now another concentration term, one or two concentration term, we are left with it. Now we are going to done with the concentration term. The last concentration term that we are going to study is parts per million. What is parts per million? The formula, the direct formula we are going to apply, it is mass of solute by mass of solution into 10 raised to power 6. Okay, that is parts per million. Do not get confused about the percentage of the solution. That was a very different topic. This is parts per million. What is the formula of parts per million? It is denoted by ppm. ppm is equals to mass of solute upon mass of the solution. Solution, again you have to take the solute and solvent, and then you have to multiply it by 10 raised to power 6. Are you getting? So we are done with the concentration term. In the next video I am going to discuss the numerical that are based on the concentration term. All the concentration term we are going to practice the numerical from NCERT and from for other various competitive examination point of view. So if you like this, if you find this video helpful, please do not forget to like, share this video, and of course to subscribe my channel. This is Rashika Singh. Have a nice day and all the very best.